Dear all the students of B.Tech first year, I am Dr. Ravin Parsai, Associate Professor of Mathematics in Engineering Science Humanity Department at Jamia Devi Group of Institution Indore. I want to teach you in this fifth lecture solution of system of homogeneous linear algebraic equation. So in our previous class we have seen the system of non-homogeneous equation. Today in this lecture we will see how you will solve the system of linear homogeneous equations by using matrix method as echelon form. So first we discuss the method, then we see an examples. Let us consider a system of m equation in unknowns. So a11 of x1 plus a12 of x2 plus a1n of xn equal to 0, a21 of x1, then a22 of x2 a2n of xn equal to 0, up to am1 of x1, am2 of x2 plus amn of xn equal to 0. So in this case also first we write the augmented matrix from the given system of equation. So this is our form of augmented matrix by writing the coefficient of the given equation in first row, and the right hand side constant you write 0 as given in the question, so 0. So then you come to the second row, a21, a22, a2n of 0, and so on. We may continue in this how many equation you have been given. So am1, am2, amn of 0. So now by a series of elementary row transformation we can reduce the above this matrix to echelon forms, and then we find say a1 b1 of a of b, that is the echelon form of the augmented matrix. So if you have to find the rank of this augmented matrix, you will count the number of non-zero rows in the echelon form AB, that is a1 b1. Say it is R, and the coefficient matrix rank is also you will find by counting the number of non-zero rows in the echelon form of A, that is of A1. So let me suppose the rank is R, number of non-zero rows are S. So and n is the number of unknowns whatever may be given to you. Now we draw the conclusions from above, as if rank of a coefficient augmented matrix equal to rank of coefficient matrix, then the system is consistent. Now we know that in this consistency of system equation you are having two category, one having unique solution. So when augmented matrix rank equal to rank of coefficient matrix equal to number of unknowns, then the system has a unique solution or a trivial solution, and this trivial solution is always of this type x1, x2, x3 all are to be 0, that is you are saying that is a 0 solution. Now you come to the second categories when rank of this augmented matrix and the coefficient matrix are same but less than number of unknowns, then in this case system have a many solution or a non-trivial solution. So let me see an examples and we note down some note here. The system of homogeneous linear algebraic equations are always consistent. This is first important conclusion, and the second important conclusion is if the determinant of coefficient matrix is non-equal to 0, then we have unique solution, that is x1, x2, x3, xn equal to 0, and if the coefficient matrix determinant equal to 0, then we may have many solution, or we can say that non-trivial solutions. So let us we examine the examples here. So first example is examine whether the following system of equation are consistent or not. If it is consistent, then solve it. So this is the example. First your duty to arrange into this pattern by writing left side of the given equation all unknown terms and the constant term on the right hand side. This type of arrangement you will do in each pattern for each component of the system of linear algebraic equations. That's why we write here. And now we write first the augmented matrix of this system of equations AB. So 1 3 minus 2 0, 2 minus 1 4 0, 1 minus 11 14 and 0. So now you are having the job to make below elements to 0. So for this I am applying R2 minus 2 R1 and on applying R3 minus R1. So by this reduces to first row as it is 1 3 minus 2 0, then 2 minus 2 0, so minus 1 3 2 is 6, so minus 7, 4 plus of this minus 1 is plus 2, so 2 2 are 4, so 4 plus 4 8, this is as it is. Now we come to the third row by applying these third operations. So 1 minus of 11 minus 11 and minus 3 is minus 14, we are on 14 minus of minus 2, that is 16, and this is equal to 0. So now the next step is you make this position element to 0 with the help of these elements. So you are applying R3 minus 2 R2. So by this you are getting this matrix 1 3 minus 2 0, 0 minus 7 8 0, 0 0 0. That is, it is an echelon form, say by A1 B1. So now we count the rank of the coefficient matrix and the rank of the coefficient matrix and augmented matrix. So the coefficient matrix rank is 2 and augmented matrix rank is 2, because both in this whole matrix non-zero rows are 2, and in this part this coefficient matrix having non-zero rows are 2. So that's why both are equal, that is the system is consistent, but you are having 3 number of unknowns. So that's why here this figure is less than number of unknowns, therefore system is consistent, has many solution or non-trivial solution. It forms as follows, as we have discussed in the previous class, how you find the many solution, and accordingly you also continue in this case. So by writing the matrix equation A1 of x equal to B1, 1 3 minus 2, 0 minus 7 8, 0 0 0, so x y z 0 0. So now we multiply this matrix by this matrix, you will get x plus 3y minus 2z. Second row you are getting minus 2y plus 8z, and the third row is 0 equal to 0. So now therefore on simplifying this, you are getting this x plus 3y minus 2z equal to 0. First one equation, second one is minus 7y plus 8z equal to 0. And now since we are having total number of unknowns are 3, and while you are having 2 equations, so this is the way of finding number of independent variables. So this difference, the total number of unknowns minus the number of equation you obtain here, so this difference gives to you the number of independent variables. So therefore one variable is independent. You can choose any one of these, either x or y or z. I take here z equal to k, any real values. So from this k you will put z equal to k. In second one you will get y. When you use z and y in equation 1, you will get x. X is minus 10k upon 7. Just you are putting and obtaining these values. Now we come to the second one more example of this same techniques. So we have to determine this unknown b, for which the system has a unique solution or trivial solution, and the second option is an infinite number of solution, because we know that we are having in homogeneous case only 2 category, either one solution or many solutions. So that's why, because the system is always consistent. So first you write the system equation in the standard pattern already given in the question, all variable terms in left side and the constant term on the right hand side. You write the augmented matrix 2 1 2 0 1 1 3 0 4 3 b 0. Now you make analogous way this position to 0, and just for this, because I want to make this position to 1, I just interchange first row with second row. So using these transformations 1 1 3 0 and 2 1 2 0 and 4 3 b 0. And now you have the process of making these elements to 0 on applying this case as on applying R2 minus 4 to R1 and on applying R3 minus 4 on 1. By this also to be become 0. So the balance is this. So now you are getting this, you obtain these values to here. So 1 1 3 0 0 minus 1 minus 4 0 0 0 0 b minus 8 of 0. So now this is your the position of echelon forms. Now we have the possibilities. Hence we have for a unique solution or a trivial solution, we know that what is the case. Rank of augmented matrix equal to rank of coefficient matrix, and number of unknowns are also to be counted. So when these both are to be equal and equal to number of unknowns, then only in this case this is to be possible for a unique solution. So that's why if b is not equal to 8, when you are not taking b equal to 8, then only this is to be possible here. So now we come to the case of infinite number of solution or a non-trivial solution. For this case, when it arises, so if you put b equal to 8, in this case you are having this coefficient matrix rank is 2, and those whole matrix, that is augmented matrix, also rank to be is 2. So both the ranks are equal and less than number of unknowns, that is the case of many solution, you can easily obtain. So now we come to conclude the infinite solution by writing the metric equations. So 1 1 3 0 minus 1 minus 4 0 0 and x y z 0 0 0. So that is the right hand side. Now you multiply this matrix by this, x plus y plus 3z minus y minus 4z, and the last is 0. Now you write in algebraic forms x plus y plus 3z equal to 0 minus y minus 4z equal to 0. Now you have to obtain how many variables are independents. So the method is same. How many number of unknowns? 3, and number of equation you have to obtain from this echelon form on solving the equation is are 2. So 3 minus 2 equal to 1. Here also we are having one independent variable. So let me suppose z equal to k, and k is any real values. So just you substitute this in the second one equation, you will get y equal to minus 4k, and when you substitute y and z in first one, you will get x equal to k. Just putting this y equal to minus 4k or minus 3k, so you are getting minus k. When you shift this side, so you will get x equal to k.